nearshore is a quite extensive zone. It's starting way out at the edge of where light can penetrate until it's hitting the bottom of the water. And that's where light can drive photosynthesis to allow things like algae and eelgrass to grow up from the bottom. And it's extending way up the hillside to the top of the bluff, or in the case of where fresh water is entering the shoreline, to the head of the tide, the head of the place where even the fresh water is going up and down with the tide. And the reason that's important is we're finding out as we study the nearshore processes that there's a lot of energy that's transferred between the water and the uplands, and from the uplands on down to the beach. There's a transfer of materials like wood, like leaves that form detritus. Fresh water is coming down from the shoreline, and the saltwater nutrients from the critters that are being eaten by crows and gulls and things like that are being carried up into the uplands, and those nutrients are helping to support the trees there. So as we're looking at this zone of two very different communities between the freshwater dominated and terrestrial environment and the marine environment of Puget Sound, we're trying to define this area where there's a lot of flow of materials and energy between those two zones, and we're calling that the nearshore. Here I am high up on the beach, but I'm still sitting in a big puddle of water, and you may not be able to see this, but the water's flowing by me from the uphill to the downhill. An important thing about Puget Sound beaches is that they're always bleeding fresh water. And all of the shoreline geology here that you heard Hugh Shipman talk about is kind of stacking up fresh water in the uplands and allowing it to bleed out into the beaches. That mixing of the fresh water along this shallow water edge of the salt water is creating a lower salinity zone. The salinity is the amount of salt dissolved in the water. We call that mix of fresh and salt water brackish water. Brackish water conditions are really important for a lot of animals living in the intertidal zone, especially young salmon. As they're migrating from freshwater to saltwater, they need to hang out in these intermediate salinity zones so that they can make the transition to be a saltwater creature as an adult. So I'm standing here, sitting here and actually being able to taste the water, and it's not quite fresh. I wouldn't want to drink a big glass of it, but it's considerably less salty than the water that's behind me in the bay. This upper intertidal area is a very important place biologically. The trees that are above us are obviously providing shade from their branches. As the wood falls down from the branches or from the trunks onto the beach, it's helping to create beach structure and that microclimate, the little places where fresh water and shade can be on the beach that help certain things get established. And there's a lot of terrestrial insects that we don't even realize that drop off of the leaves onto the beach all the time. There's some recent research about salmon migrating along the shoreline. We're finding a lot of terrestrial insects in their stomachs, and that means it's very important to maintain a forested shoreline. While this may not look too appetizing to you and me, all these dead things are mixing together in this upper intertidal zone, being coated with algae, being coated with fungus, being torn down into smaller and smaller pieces that we call detritus. Now, detritus is flowing out into Puget Sound and being processed by lots of other animals throughout the year, and it's probably as important of a food source as the phytoplankton and the zooplankton that are occurring out in the oceanic parts of the Sound. A really important thing as we're standing in this high intertidal zone is the interaction between wood and the sediments of the beaches. There is a large western red cedar tree, and it is leaning over onto the beach and will eventually fall onto the beach. This is a really important source of wood, and it does a number of things. It harbors lots of beach hoppers. As you turn over a piece of wood, you'll see that moister, cooler environment where the beach hoppers can hang out, and they're going to be taking the small piece of vegetation, the leaves and the algae, and turning it into detritus. And the wood is also going to move around on the beach and create small microclimate areas where other vegetation can take hold. So we're up here in the upper intertidal part of the beach, and the sandy consistency of this harbors a number of organisms that you don't see further down on the beach. For example, as I move algae off the beach, there's a number of little beach hoppers that are breaking this down into smaller particles. Those particles are sinking down into the sand, and they're helping the sand to retain moisture. There's several species of forage fish. The one that's going to use sandy soils like this for its spawning is the sand lance. And Pacific sandlance are going to come up here during a high tide. They're going to lay their eggs into the sand, and those eggs will incubate into the wet sand for about 2 weeks while the water level stays below this area. The moisture that's retained by the small bits of algae is going to be a perfect temperature and moisture for those eggs to incubate. In about 2 weeks, the high tide will come back to this level, and the small fish will emerge from their eggs and then go out into the water. Sandlance are particularly susceptible to any disruptions of this upper intertidal zone. So as people do bulkheading along the shoreline and disrupt those natural sediment transport processes, this elevation and this slope and this particularly very narrow area for sandlance to spawn might disappear from the beach. Just a few feet above the beach from where we were with the sandy substrate, we have a mix of sand and gravel. This kind of pea-sized gravel is a spawning bed for the surf smelt. The surf smelt is a little bit larger fish than the sandlance. The surf smelt eggs are going to be sticky, and they're going to stick in between the sand grains and kind of have sand and gravel grains all around them. So the sandlance and the surf smelt, specifically the surf smelt, are up in this highest part of the intertidal beach, need the shade of overhanging trees and the leaves that are dropping in to be able to support their spawning conditions. Now, as these young forage fish, the sandlance and the surf smelt, emerge, they're going to become a very important food source for migrating salmon that are going to be coming out of the rivers, moving along the shoreline looking for food, ducking into these low salinity areas near streams, and they're going to be feeding on forage fish juveniles. As those forage fish mature out into the sound, they'll become food for lots of other things too. As we're building along the shoreline, as we build bulkheads and we clear that native vegetation off the beach, we are reducing the amount of food, the amount of wood, and the amount of leaves for the detritus that gets ground up by these amphipods. Mudflats are more productive than people give them credit for. There's this diatom film. It's a single-celled plant that is really taking advantage of the sunlight hitting this dark surface, and it's very warm. And these single-celled plants can grow extremely fast and form a film, this kind of orangish brown film across the surface of the sand. It's a very important food source for all kinds of things that are living below the sand and over top of it. For example, the clams will bring in a suspension of both floating particles from the water column, and they'll also kind of vacuum up the surface with their siphons as they get this film into their bodies, and it's a good source of nourishment for them. Some of the neat things to do when you're along the beach is to turn over rocks and look at what's growing on the undersides. A lot of times the low tide is going to stress a lot of the animals on the beach, and they're going to seek shade and water, and there's usually water that's gathered in the pockets underneath the rock. But it's really important that after you've looked, that you roll those rocks back to where you found them and cover them back up. These are green shore crabs. There's a couple different species of shore crabs that live usually under rocks or around. Low tide usually has them hiding out so they can avoid the sun and the heat and the drying conditions of low tide. Once the tide water comes back over top of them, they go out and forage, and they'll eat algae, and they'll eat little bits of barnacles or whatever other dead meat might be laying around on the beach floor. Well, barnacles are a pretty common sight on most beaches. Barnacles will cement themselves when they're very young to a large or rock or even a small cobble. And the barnacles will spawn en masse, really filling the water column with lots of larvae, and it's a really important food source. Also, if you look at those feeding tentacles, the little arms that are coming out of the barnacle gathering food, just like another crab or a shrimp, they have to shed their shells in order to grow. I know it's really tempting when you're on the beach to pick up sand dollars, and I would say in Tulby State Park and a lot of places like it, this is $1 million beach. There's as many sand dollars as I've seen anywhere. It's very important when you're around sand dollars to step lightly on the beach and be careful where you are, because they're generally right underneath the sand, only a few inches. If you find a live one like this, which is all covered with these brown spines and little hairs, that you place him back on the beach, right side up, just like that, and he'll bury himself back in. If you want to collect a souvenir, there's plenty of dead sand dollars, usually looking gray to white in various stages of completeness, and you might want to take that home, rinse them with fresh water, and let them dry out in the sun. But otherwise, please don't collect the live sand dollars because they are living creatures and they do need to be back here in the sand to survive. This little gelatinous mass here is a group of sculpin eggs. There's several species of sculpins. They live in the intertidal zone and they will get together and breed and lay these egg masses. It'll take a few weeks for the eggs to hatch out, and then the young will find their way into the sand to hide out until they're large enough to fend for themselves. Well, a lot of times you'll also see on the beach these little volcanoes with holes in the middle. It's kind of hard to tell whether you're going to find a clam in there or a sand shrimp or mud shrimp, but we'll dig into this one and see what we find. Now, just like I said with the sand dollars, it's really important anytime you dig a hole in the beach to replace the sand kind of the way you found it, and that way anything that might have been displaced by your digging will not be hurt. Here's a young bent nose clam. They start out without a bent nose, but as they get larger, the top shell where the siphon comes out begins to bend to one direction. And here's the shell of a cockle. It's another bivalve, another small clam that can actually get up to about that size, maybe weigh a half a pound or more. And you'll often find cockles used to make clam chowder, along with some of the larger clams like horse clams and gooey ducks. There's a number of worms that will dig into the sand, and they'll use a mucus that they secrete, and they'll use the smallest sand and mud grains to cement them together into a tube, and that tube becomes their home. So you can see this worm tube that went a good 6 inches down into the sediment, but the worm doesn't seem to be home, or he's dug himself out of the way. The worm is a really important food source for a lot of the migrating shorebirds. We've seen some yellowlegs here on the beach and some other sanderlings and things like that are going to move across the shore. They're going to find these tubes and they're going to rip the whole thing out much faster than I could, and they'll be able to tear the tube open and get the worm out. This is the shed exoskeleton of a Dungeness crab. Dungeness crab will come into shallow areas like this and use the osmotic pressure of the fresh water to help break their shells open. This is a horsehair crab, and that shell will stay soft for the next 24 hours or so. While it hardens up, they'll hide or bury into the sand, and then they'll kind of grow into the next one inside. One of the more common marine algae in the intertidal zone is sea lettuce, and I call it sea lettuce because it's actually pretty tasty. It's a little on the salty side, but a lot of folks will dry it and put it on salads. It's packed full of vitamins. If you got hungry on the beach and needed to survive, this will carry you for at least a day or two. This is laver, and this is one of the main ingredients in sushi. So all of these communities are connected, and they're happening right at this place at the highest tide line, where the interaction of the terrestrial environment and the marine environment are producing a really unique and special place.